wonderful world of physics. Have you seen a magnet? Did you notice the amazing powers? It's wonderful, isn't it? There is a very interesting story behind the invention of magnets. Magnetism was first discovered over 20 centuries ago by a shepherd named Magnus who lived in Magnesia, Greece. While herding his sheep between the mountains, he suddenly noticed that the tip of his stick and the nail on his shoe got stuck on a rock. The iron part at the tip of the stick and the iron nail on his shoe were attracted to the magnetic rock. The stone was named magnetite in the memory of the shepherd and the country from where it was discovered. Magnetite is one of the 3 natural oxides of iron. This is later known as magnet, and that too it's natural. Magnets are mainly of 2 types, natural magnet and man-made magnet. The magnetic field strength of natural magnet is relatively low. We usually require powerful magnets for different purposes in different places. Thus, the need for stronger magnets led to the development of man-made magnets. Man-made magnets are further divided into 2, permanent magnet and transient magnet. Permanent magnets are usually made of alloys, example alnico, a ferromagnetic material. As the name implies, it's an alloy of aluminium, nickel, cobalt and iron. Temporary magnets can be made in 2 ways. First one is with the help of permanent magnet. When an object such as needle or iron etc. is kept near the permanent magnet within the magnetic field, they experience some sort of magnetic effect and act as a magnet. Now, the second method, it is possible to make a temporary magnet with the help of electricity. When electricity flows through the solenoid, it acts as a magnet as long as there is current in the solenoid. That is, it is acting as a temporary magnet. The magnets that are made using this principle are called as electromagnets. Now, let us study them in details. Let us see some of the permanent magnets: a bar magnet, ring magnet, U-magnet, button magnet, cylindrical magnet, horseshoe magnet, etc. Here, we can see a very heavy metal container being loaded into the ship. For this, we have used powerful cranes. In such cranes, there are powerful electromagnets. Don't you want to know about electromagnets which are highly powerful? In this chapter, we are going to learn in detail about electromagnets and magnetic effect. This is a magnet, a bar magnet, which has 2 poles. Not only bar magnet, but all types of magnets are having 2 poles. A north pole denoted by the letter capital N and a south pole denoted by a letter capital S. How can you identify the poles of a magnet? Here we can see a dot on one side, and this side is what we called as a north pole. Then the other side would be the south pole S. The maximum magnetic strength is experienced at the pole. This is because the poles are having high magnetic field. Magnets might attract or repel. Let's see what it looks like. South pole repels south pole because they are like poles. If unlike poles come in contact, they would attract each other. That is, when north pole comes in contact with the south pole, they attract each other. There is a space around the magnet in which the force of magnet is felt. This region is called as a magnetic field. It is 3-dimensional. The strength of magnetic field is maximum at the poles. And we can see that as the distance from the magnet increases, the strength of the magnetic field decreases. Take a look at this. I am having an iron rod in my hand. What happens if I hold the iron rod away from the magnet and release it? Yes, it will fall down. Why? This is because it is away from the magnetic field. Now, let me hold it a bit closer to the magnet. See what they attract? This is because the iron rod is within the magnetic field and the magnetic field strength is higher. So, from this, what we can infer? If any magnetic object is placed in the magnetic field, then they will attract to the magnet. This is because the magnetic field strength is higher. If these objects are kept out of the magnetic field, the magnet does not attract them. This is because the magnetic field strength decreases as the distance from the magnet increases. Within the magnetic field, there is an imaginary line through which the force of magnet is acting. Such imaginary lines are called magnetic field lines. Externally, these lines are from the North Pole to the South Pole. Internally, they are from the South Pole of the magnet to the North Pole. You might be familiar with this object. They are usually used to find out the direction while tracking. But how do they show us the direction? Tie a string at the center of the bar magnet and allow them to move freely. The magnet oscillates and comes to rest in a particular direction. To be precise, if we hold a magnet above the surface of the earth, the magnet would automatically adjust according to the geographical direction of the earth. That is, the north pole of the magnet is aligned in accordance with the earth's geographical north pole, and the south pole of the magnet is aligned according to the earth's geographical south pole. Here, something is very interesting. Did you notice? It might be a new information. We can consider our earth as a big magnet. There is an area around the earth that feels its own magnetic field, and there are magnetic field lines moving inward. If we look at the direction of magnetic field lines here, we know that the field lines are from the north to the south pole. So, if we consider earth as a magnet, the north pole of the magnet will be the geographical south pole of the earth, and the south pole of the magnet will be the geographical north pole of the earth. Thus, the north pole of the magnet, which is free at the earth's surface, is attracted to the south pole, and the south pole is attracted to the north pole of the earth's magnet. In short, the north pole of any magnet that is independent on the earth's surface is attracted to the south pole of the earth's magnetic field, that is, to the earth's geographical north pole, and the south pole of any magnet is attracted to the north pole of earth's magnetic field, that is, the geographical south pole. The magnetic compass is a device that works on this principle. Here, there is a magnetic needle that can move freely. If the needle shows north-south direction, we can understand that the rest of the directions from it. We have realized that the compass with the magnetic needle would be adjusted according to the Earth's magnetic field. Therefore, we also use them to detect the presence of magnetic field lines. This is just a simple introduction. We are yet to learn more. See you.
Enclaps.